science has confirmed the impossible. Mercury, the scorched iron heart of our system, is not just a rock. It is a comet in disguise. It drags a phantom limb behind it, a tail stretching 2.5 million kilometers into the void. Imagine standing on that burning surface. You are hurtling through space at 48 kilometers per second, towing a veil of gas 500 times larger than your own home. It is a majestic, terrifying sight. Back in 2001, when astronomers first captured this, it defied logic. Planets don't have tails, but NASA's Messenger probe spent 4 years orbiting this hellscape to bring us a darker truth. This tail isn't just decoration, it is evidence of a cosmic flaying. The Sun is peeling Mercury alive. Let's visualize the scale. 2.5 million kilometers. Line up the Earth, one after another, and you would need 190 of them to fill the length of this scar. A tiny rock, barely 5,000 kilometers wide, casting a shadow that swallows the inner solar system. It sounds absurd. So why can't we see it? Why isn't the sky filled with this yellow slash? The answer lies in the spectrum. This tail is made of sodium atoms, the same salt on your dinner table, glowing with a faint yellow light at 589 nanometers. It is a ghost signal, drowned out by the blinding roar of the sun. To the naked eye, Mercury is just a dot. But filter out the glare, isolate that specific frequency, and the invisible becomes a titan. It's like standing in a stadium flooded with searchlights, trying to spot a single lit match. But put on the right glasses, and suddenly, that match is the only thing you see. The prediction came long before the proof. In the 1980s, scientists at the Max Planck Institute saw the math, but it wasn't until 2001 that American astronomer Andrew Potter, armed with a massive solar telescope, finally caught the ghost in the lens. But finding the tail only led to a more disturbing question. How does a dead rock generate a comet's trail? To understand the anatomy of this beast, you have to stand on its skin. Mercury is a world of bipolar extremes. By day, the temperature screams at 427 degrees Celsius, hot enough to turn solid lead into a running river. By night, it plunges to 173 degrees below zero, a 600-degree swing that cracks reality in half. But the heat isn't the killer. The exposure is. Mercury is too small. Its gravity is too weak to hold a shield. Earth is wrapped in a thick atmospheric blanket, over 100 kilometers deep. Mercury. It has nothing but an exosphere, a layer so thin it's technically a vacuum. If Earth's air is a heavy winter quilt, Mercury's atmosphere is the dust settling on top of it. This fragility is the fuel. So how do atoms escape the rock and enter the void? Through 3 acts of celestial violence. First, photon-stimulated desorption. Sunlight here isn't just brightness, it's a physical hammer. Photons slam into the surface with enough kinetic rage to kick sodium atoms loose from the crust. Second, micrometeoroid bombardment. The inner solar system is a shooting gallery of high-speed dust. These invisible bullets hit Mercury at tens of kilometers per second, vaporizing rock on impact and launching debris upward. And third, solar wind, sputtering. A relentless stream of charged particles from the sun acting like a plasma cutter, blasting atoms straight off the surface. The violence doesn't end at the surface. Once an atom is kicked loose, logic dictates it should fall back down. Gravity demands it. But in this inferno, light is a physical force. It's called solar radiation pressure. We tend to think of light as intangible, but photons carry momentum. When sunlight slams into a suspended sodium atom, it is absorbed and re-emitted, imparting a tiny, relentless kick. On Earth, this force is negligible. On Mercury, it is a titan. The pressure is so intense it counteracts 54% of the planet's gravity. It acts like a cosmic wind, grabbing any atom moving faster than 2 kilometers per second and shoving it away from the Sun. These atoms are accelerated to 11 kilometers per second, terminal escape velocity. They are lost forever, joining that golden river flowing into the dark. It is a hemorrhage on a planetary scale. Every single second, 100 quintillion atoms are ripped from the world and cast into the tail. But the strangest part, the tail isn't dead. It breathes. NASA's Messenger probe watched this phenomenon for 4 years and noticed a pulse. The tail's brightness fluctuates, glowing 10 to 20 times more intense at specific points in Mercury's orbit. This is the Doppler effect, weaponized by gravity. When Mercury rushes toward the Sun, the light shifts blue. The atoms absorb more energy, and the tail flares violently. When it retreats, the tail dims. It pulses in rhythm with its torture, but where is all this material coming from? If Mercury is leaking, will it eventually bleed out? Scientists estimate that while most ejected atoms fall back to the surface like toxic rain, a fraction is lost to the void forever. And it's not just sodium. We've detected calcium, magnesium, potassium. The very bones of the planet are being vaporized. Mercury is slowly shrinking. The Sun is carving it down, atom by atom. That beautiful golden tail is effectively a wound. It is the visible sign of a planet bleeding into space. You might ask, will the Sun eventually consume Mercury entirely? Will it be whittled down to nothing? In theory, yes, but the timeline is vast. At the current rate of decay, Mercury has billions of years left. Time enough for the Sun itself to evolve into a red giant and swallow the planet whole in a final fiery embrace. But this discovery serves as a warning. Mercury is the canary in the coal mine. In the deeper cosmos, we have found others suffering the same fate, but on a terrifying scale. Take Gliese 436b, a hot Neptune located 33 light-years away. It orbits just 4 million kilometers from its star. It is evaporating. Its hydrogen atmosphere is being stripped away so violently that it trails a cloud deeper and darker than anything in our own system. The universe is likely filled with these evaporating worlds, planets slowly being digested by their own stars. So the next time you look toward the horizon and catch a glimpse of that elusive, swift-moving dot, remember what you are seeing. You are not looking at a static rock. You are witnessing a billions-of-year-long funeral procession. Mercury is writing its own history with its own body, scattering its bones into the solar wind. Every sodium atom drifting in that invisible tail is a tear from a dying world. The loneliest traveler in the system, slowly fading into the light. Good night.